crew. These are our Unit 4-1 notes. In Unit 4, we look at what we call trigonometric properties or identities. These can be referred to identities because they give expressions which don't look alike but are equivalent to each other. Think of it this way. You come to school in a certain type of dress, right? And we recognize you, right? You look like you by the way that you dress. But if you were to go to a homecoming banquet or to the beach, your outer appearance would be different. You would look different on the outside, but you are still the same person. Your identity has not changed. So we're going to look at expressions that look differently, right, at first glance, but they are actually equivalent to each other. Their identity is the same. So we're going to look at these because our job in algebra is fourfold. We look to write expressions and simplify them, and then write equations and solve them. And we can use these trig identities to simplify trigonometric expressions, and we can use them to solve trigonometric equations. And we'll see how that plays out as we go along. So in these first notes, we're going to look at 4 sets of properties or identities. Our first set are called the reciprocal properties. Okay, so this is set number 1. The reciprocal properties define or give an equivalent to one trigonometric function as the reciprocal of another. So hopefully this is not new to you. We know that the secant of x is the reciprocal of the cosine of x. So the secant of x is 1 divided by cosine. Likewise, the cosine of x is 1 divided by the secant of x. The cosecant of x we know is 1 over the sine of x, and the sine 1 over the cosecant of x. So sine and cosecant are reciprocals of each other. Cotangent is 1 over the tangent of x, and the tangent of x is 1 over the cotangent of x. So cotangent of x and tangent of x are reciprocals of each other. Now we can take these properties and we can write them in a slightly different way. Right? If we take the secant of x equals 1 over the cosine, and we multiply both sides by the cosine of x, right, then that becomes equivalent to, right, the cosine of x times the secant of x equals 1. So both of these have an equivalent identity that says that 1 is the same thing as the cosine and the secant. And if you think about it, that makes sense because we know that these are reciprocals, and we know that if we take a number and we multiply it by its reciprocal, we always get 1. This is called the property of reciprocals. You're going to reference this in your classwork probably more than once. So likewise, we could take that the cosecant equals 1 over sine, the sine equals 1 over cosecant, and if we solve here for 1 by multiplying both sides by the sine, we would get that the sine of x times the cosecant of x equals 1. And likewise with these two properties, we could get that the tangent of x times the cotangent of x equals 1. So in our reciprocal properties, we have 6 reciprocal properties, or we can even think of that as 9 reciprocal properties when we add these last 3. So our first set are reciprocal properties, which define one function as the reciprocal of another. Now we're going to look at our second set, which are quotient properties, and we're going to learn 4 of those. So the quotient properties give one trigonometric function as the quotient of 2 others. Our first one is the tangent, which is the quotient of the sine of x over the cosine of x. And the cotangent, right, as the tangent and cotangent are reciprocals, we flip that fraction and we get that the cotangent of x is the cosine of x over the sine of x. So those are our first 2 quotient properties. We have 2 more, which are different identities for the tangent and cotangent as a quotient of 2 other functions. And we're going to look at the proof for the tangent. Okay? So what we already know is that the tangent of x equals the sine of x divided by the cosine of x. Now, if we replace both the sine of x and the cosine of x with their reciprocal identities, let's go back up to the top. We remember that the sine of x is the same thing as, right, 1 over the cosecant of x. And the cosine of x is the same thing as 1 over the secant of x. So if we use those as replacements for sine and cosine, we get sine is 1 over the cosecant of x. Cosine is 1 over the sine of x. We're dividing two fractions, so that's the same thing as taking the top fraction, 1 over the cosecant, and then multiplying it by the reciprocal of this bottom fraction, which is, this was 1 over the secant of x. So we'll multiply by the secant of x over 1, right? Multiplying fraction is no big problem. We multiply the tops, we get secant of x. We multiply the bottoms, and we get cosecant of x. So our tangent of x, right, is also the quotient of our secant of x times our cosecant of x. Now, one thing you might notice about these two is these are both an s function over a c function, sine over cosine, secant over cosecant. So if we look at a cotangent of x and we run through that proof, we have our cotangent of x equals cosine of x over sine of x, replacing each of those functions with their reciprocals. So we get 1 over secant of x divided by sine, which is 1 over cosecant of x, which is 1 over the secant of x times the flip of the bottom fraction. So that would be the cosecant of x over 1. Multiply the tops and the bottoms, and we get cosecant of x over secant of x. So our quotient identity for cotangent, cosine over sine, and as well cosecant of x over secant of x. So you might notice about these two that these are both c functions over s functions. All right, so two sets of properties. We have reciprocal, we have quotient, we have one more set we're going to look at. Right, very important set we use a lot. These are the Pythagorean properties, and these are based, right, these Pythagorean properties are based on the Pythagorean theorem, which says that for a right triangle, if one leg is A and another leg is B and the hypotenuse is C, that it's always true that A squared plus B squared equals C squared. So our first Pythagorean property, right, we're going to have 9 of them. But our first one is that the sine squared plus the cosine squared equals 1. Let me quickly show you where that comes from. If we come and look at our unit circle in standard position, and we take a point on that unit circle, so I'm going to put a point here, and we call the coordinates of that point UV, right? We've done this before. We can come back here and we can, right, make a right triangle where, because this is u, we know that the horizontal leg would be u. Because the y coordinate is v, we know the length of the vertical leg would be v. And because this is a unit circle, we know the hypotenuse would be 1. Well, there are a couple things we know here. We know that u will give us, right, the x-coordinate, give us the cosine of our angle. So if we call this angle x, u gives us the cosine of x. We know that v, the y-coordinate, will give us the sine of x. So we know those two things. Okay. The other thing we know is that given a right triangle, we know that leg squared, u squared, plus the other leg squared, v squared, must equal the hypotenuse squared, which is 1 squared. So if we take these two and we put them together, then we get for u, right, u is the cosine of x, we get the cosine of x squared plus v, v is the sine of x, so we get the sine of x squared equals 1 squared, which is 1. Just in more efficient mathematical notation, when we're squaring a function, we can put the superscript on the function, so we can write this as cosine squared x plus sine squared x equals 1. And that is our first Pythagorean identity. So, right, so we have the proof of that. Now, the next two, so this is our second identity and our third, all come directly from that identity. So if we take this equation and we solve it for sine squared by subtracting our cosine squared, we get sine squared equals 1 minus cosine squared of x. That's our second one. If we come in here and we solve for cosine by subtracting the sine, then we get cosine squared equals 1 minus sine squared of x. So if you can remember this first Pythagorean identity, sine squared of x plus cosine squared of x equals 1, you can easily solve for either sine or cosine squared and get two other identities. Now, let's look at this third identity. So my third identity is 1 plus the tangent squared of x equals cosecant squared of x. And that identity is going to come also from this first Pythagorean identity. So let me show you where that comes from. Okay, and I'm going to, just so I can keep this in view, I'm going to erase this so I can use this space. You should have room on your notes to fill this in elsewhere. And I'm going to start here with my, well, let's do this in green. I'm going to start with sine squared of x plus cosine squared of x equals 1. Now I'm going to change this, transform it, so I have secant squared on this right-hand side. Well, I know that secant is 1 divided by cosine, so secant squared will be 1 divided by cosine squared. So if I divide this 1 by the cosine squared of x, then it will become the secant squared of x, right? That's our reciprocal identity. Well, I can do anything I want to an equation if I do it to both sides, so I have to divide the other side by cosine squared. When I'm dividing a sum by one thing, I have to distribute that division. So I'm going to break up this fraction to the sine squared of x over cosine squared of x plus a cosine squared of x over cosine squared of x. Okay. Think about this a minute, right? Don't these two fractions have a common denominator? If I add them, I add the tops, right? Sine squared plus cosine squared gives me sine squared plus cosine squared, and I put it over the common denominator. These two statements are equivalent. If I now simplify those using our identities, our quotient identity says sine divided by cosine equals tangent, so sine squared divided by cosine squared is going to be tangent squared of x, plus anything divided by itself is 1, so I get tangent squared of x plus 1 equals secant squared of x. And this is, right, this is our third identity. If we do like we did here, we can get the fourth and the fifth by directly solving this first statement. So if I solve 1 plus tangent squared for tangent squared by subtracting the 1, I get tangent squared is secant squared of x minus 1. If I solve for 1 by subtracting the tangent squared, I get 1 equals secant squared of x minus tangent squared of x. Now, similarly, I can get my sixth identity from my first identity. So I'm going to come in here and get the first. So we're going to start again with sine squared of x plus cosine squared of x equals 1. This time I'd like a cosecant squared, and since 1 divided by the sine of x is cosecant, then 1 divided by sine squared will be cosecant squared. We're going to divide both sides by sine squared, split up my fraction on the left, and I get sine squared over sine squared plus cosine squared over sine squared equals 1 over sine squared, which is the cosecant squared. Sine squared over sine squared is 1. Cosine over sine is cotangent. So cosine squared over sine squared is cotangent squared of x equals cosecant squared of x. Right? So that's what I have in 6, 7, and 8. 1, 2, 3. Oh, I misnumbered. Shoot. This should be 4. This should be 5. This should be 6. This should be 7. This is 8. This is 9. Right? Solving for cotangent, subtracting 1, I get that cotangent squared is cosecant squared of x minus 1. Right? Subtracting cotangent squared, I get 1 is cosecant squared of x minus cotangent squared of x. So altogether, we had 6 plus 4, that's 10, plus 9, that's a total of 19 identities. You need to memorize, know all of these identities backwards and forwards, and your first quiz will be next week, and we'll be over those identities. Well, that takes care of our notes. You'll be practicing that, and I will see you tomorrow.